Good morning, teacher.
I hope we are fine. Do we have any questions? Any numbers that challenged us before teacher can introduce whatever he wants to put across? I remember we had introduced the T formula. Yes, Swale, your hand is up. You have a number? Swale?
Yes, sir.
Yes, please. Your hand is up.
Morning, sir.
Good morning, God. Sorry.
Sir, the exercise that you gave us, number 3.
Number 3. It was on T formula. What was it saying? You read to me.
2x power 6.
What?
2x power 6.
2x power 6. Oh, where was that? Hey, the exercise from Tranta.
Yes.
Okay.
2x power 6.
Was number 6.
It was letter C.
Was number C.
Yes.
No, you can't see. Okay, you read it. 2x power 6. Wait. We are in trigonometry, Sware. You are bringing a polynomial, I think.
Yeah, polynomials.
Polynomial, I can go to the inbox. Today it's for trigonometry. I want those challenges of trigonometry. Either I will handle it in the polynomial day, or you can inbox it to me before the polynomial day. Then I see how I can help.
Okay.
Guys, we are in trigonometry and we have introduced the T formula. This T formula came from the students, no, they call it the student T. There is a student T distribution, and I think also this T formula also came from some students. Okay, so if no concern, I think we had derived, we had not solved some numbers, I'm not sure. Hadn't we solved some numbers? Guys, had we solved some numbers using the T formula?
Yes, teacher.
People don't have any challenges. Okay, there's a number here. Let me start with this one. It says if sec A minus tan A is equal to X, prove that tan half A is equal to 1 minus X over 1 plus X. This is half angle. If I let T be equal to tan a half of A, then what is tan A? Tan A is sine A over cos A, which is 2t over 1 plus t squared divided by 1 minus t squared over 1 plus t squared. Then we lose the lower one. So tan A is actually 2t over 1 minus t squared. Whereas sec A is 1 over cos A. This will be equal to 1 plus t squared over 1 minus t squared. Now, according to what they have given us, they have said 1 plus t squared over 1 minus t squared minus tan, which is 2t over 1 minus t squared. The whole of this is equal to x. So if the whole of this is equal to x, we need to make t the subject, which t is tan half a. So I will have 1 plus t squared minus 2t all divided by 1 minus t squared is equal to x. The numerator becomes 1 minus t squared over a difference of 2 squares is equal to x. I lose 1 minus t, and I'll have 1 minus t is equal to x into 1 plus t. Then I make t the subject, and I'll have xt plus t is going to be equal to 1 minus x. T, open brackets, 1 plus x is equal to 1 minus x. Therefore, t is 1 minus x out of 1 plus x. But recall, t is equal to tan a half what? A. Therefore, tan a half of a is equal to 1 minus x over 1 plus x. Hashtag proof. That was quite an interesting proof. There is another one also here. It says prove. These are just examples to beef up the definition. 2 cot over half a plus tan of a is equal to tan of a cot squared over half a. Didn't I do this number? I think I did this one. Did I? I don't recall. People, why you're not talking? You don't know whether we did the number. So it says prove that that is true. This is 2 over tan a half of a plus, this is from the left hand side. When you expand tan a, you get 2 tan a half of a over 1 minus tan squared a over 2. This will give us 2 into 1 minus tan squared a over 2 plus 2 tan squared of a half a divided by tan a over 2 into 1 minus tan squared of a over 2. The numerator becomes 2 minus 2 tan divided by tan a over 2 into 1 minus tan squared a over 2. I lose this with that. This will give me twice cot of a over 2. Now, from this definition, tan of A is equal to 2 tan of A over 2 over 1 minus tan squared of A over 2. I can make this one the subject. When I make it the subject, what does it become? It becomes 2 tan of A over 2 or is over tan of A. Do you realize that this becomes, the 2 can vanish, becomes tan A goes up. This is 1 over tan A over 2. You get a second cot A over 2. Hence proof. So that's how we had to go with that one also. So you have to be very sensitive when numbers are set and they are proofs, because those answers are always there. So we expect you to be in position to realize those answers. There is one more here I want to give you. Screenshot that, please. Okay, so if people have taken the screenshot, the next we can have number 3. If T is equal to tan.
Excuse me, teacher.
Yes, please.
Excuse me, teacher. I didn't take the screenshot.
Please do.
Thank you, teacher.
If tan I remember sharing this page of Tranta to you guys to handle. I don't know that you tried out these numbers, but no one sent me a challenge of the numbers. So that is evidence that most of you never tried them out. So here is that question. It says, if tan a half of the angle is that, express the square root of all that in terms of t. So if we want the square root, then we want the square root of this in terms of t. So first of all, we have said we have let t be equal to tan a half of the angle. Consequently, sine of theta is equal to 2t over 1 plus t squared. Whereas cosine of theta in this sense is the same as 1 minus t squared out of 1 plus t squared. When we do the substitution, we shall have 1 plus 2t over 1 plus t squared into 3 times 2t out of 1 plus t squared plus 4 into 1 minus t squared out of 1 plus t squared plus 5. But the whole of this is asking us for the square root in terms of t. What does this give us? 1 plus t squared plus 2t, all divided by 1 plus t squared, close brackets. The second one is having 6t plus 4 into 1 minus t squared plus 5 into 1 plus t squared, close brackets, all is over 1 plus t squared. The whole of this is under a square root. And people see what I've done? Yep, this is what has happened. I've cross multiplied the denominator up here. Here it's the same. Here I cross multiplied it up here. So everything has the common denominator. And if everything has the common denominator, these two are multiplying each other, but they're under a root. So I can get 1 out of 1 plus t squared outside. Then inside the brackets, we shall remain with the following. Who can give me this first term? 1 plus t squared plus 2t comes from what expansion?
1 squared plus t squared.
1 plus?
1 squared plus t squared.
No, maybe let me write it like
No, 1 plus t squared.
yeah. 1 plus t bracket squared. Then open brackets here. You will have 60 plus 40 minus 40 squared plus 5 plus 5t squared, close brackets. This is going to give us 1 plus t, or is over 1 plus t squared under the root. Under the root we shall have 10t.
How do you send it?
Plus t squared, who is that one? Plus 5. Two numbers multiplied, you get 5. Added, you get 10. Those two numbers are 5 and 2. So this will give us 1 plus t out of 1 plus t squared under the root.
No, but like.
Hey, someone expand this. This is t squared plus 10t plus 5. It must be coming from t squared plus 5t. Sorry, two numbers multiplied, you get 5, added, you get 10. They are not there. Are they there?
Yeah.
Is b squared greater than or equal to 4ac? Yes, it is. But it is going to give us decimals. Someone use a calculator and give us the solving of this quadratic. What do you get? When you solve that with a calculator, what do you get?
Negative 0.528.
Then if they are decimals, leave them. So the best way to present this, because they said if the answer in terms of t, you'll say it's 1 plus t out of 1 plus t squared into brackets t squared plus 10t plus 5 to the power a half. That is the answer. Let me check the answer they gave here. Answer is 5b.
Teacher, where has 1 plus t squared gone?
Which one?
Square.
In the square root, it has come outside. We have found its square root. Eh? We have found its square root.
On the first.
You guys, we are wrong. This is number 2. Number 2, the answer is this one. 2 for them. The answer is 1 plus t, correct, over 1 plus t squared, very correct. But this one is 3 plus t. This one is 3 plus t. Let's check our algebra again. 6t plus 4t minus 4t squared plus 5 plus 5t squared. The 5t squared subtracted the 4t, we realize the 1t squared, correct? We had the 4t, we had the 6t plus a 40, which is giving us, oh yes, yes. Have you seen the error? The error is here. I wrote 4t, yet it was supposed to be 4 times 1 is 4. That is where our trouble came from. Okay. Now let us simplify our life. That is why sometimes it is good to check on the answer and see what the answer says. I rarely check the answers, but I assume in most cases we have it, but anything can happen. So the lady was asking, where did this one go out? The power a half takes it outside to become 1 plus t out of 1 plus t squared times the square root of 6t. So we have said, we have seen 5t squared minus 4t squared gives us t squared. Then we have seen plus 6t. Now there is a 4 and a 5, which gives us a 9. 2 numbers multiplied, you get 9. Added, you get 6. Those 2 numbers are 3 and 3, which becomes 3 repeated. So t squared plus 3t plus 3t plus 9 to give us root of t into t plus 3 into t plus 3 of 1 plus t out of 1 plus t squared. This gives us 1 plus t out of 1 plus t squared times root of t plus 3 bracket squared. Find the square root, you get the final answer as 1 plus t out of 1 plus t squared, close brackets, 1 plus t, 3 plus t. Hashtag proof. You were allowed, sometimes not at all. You Cynthia, what is that? What's up? Okay. Any other proof? Your network has problems. Sorry. Take a screenshot, you'll have to follow through. Okay. You said I did all the numbers, and all the numbers I gave you have no challenge. So those were proofs concerning what? Concerning T formula. Now I would like to introduce what we call circular measures. Unless if someone has a question. I'm introducing something a little bit different, and we are calling it circular measures. Or we can say radians. So by definition, what is a radian? Is the angle subtended at the center, the angle subtended at the center of the circle by an arc to the radius of the circle. By an arc to the radius of the circle. Now, if you're to look at this is a circle. According to that circle of ours, we have an arc perhaps the center is O. We have a point here, P. And then we have this point Q. So this is an arc PQ. And OP is say of length 1 unit. This radius R is say of 1 unit. PQ is the length. Then also, if this arc has a length of 1 unit, then we can say that the angle here, then the angle POQ is equal to 1 radian. Now, if we recall, since the circumference, Leila, do you remember the circumference of a circle? Lutu Leila.
Yes, teacher.
What is the circumference of a circle?
Pi d. Pi d.
Circumference is pi d, which is the same as 2 pi r. Okay. Then the angle subtended by the whole circumference is going to be what? What is the angle subtended by the whole circumference? What is the angle of a circle? Because the whole circumference is moving through a circle. So if you move through a circle, how many degrees have you covered? Someone answer that. If you move through a circle, how many degrees have you covered?
360 degrees.
Very good, 360 degrees. Now, 360 degrees would correspond to what we call, it would mean that you've covered 2 pi in radians. So with that, 2 pi in radians is equivalent to 360 degrees. Therefore, 1 pi in radians is going to be equal to 180 degrees. Of course, the 180 comes from 360 divided by 2. So always 1 pi radians in radians is equivalent to 180 what? Degrees. Or one can also say 1 degree is equal to 2 pi out of 360 degrees. So still, one can say 1 degree is equal to 1 pi in radians out of, this is no longer degrees, out of 180. But these are in what? In radians. This is in radians. So we are converting now degrees, taking them to radians, in whatever we are going to deal with. So 1 radian is always equal to 180 degrees out of pi. So if you want to move from radians to degrees, you multiply the radians you have by 180 degrees out of pi. If you want to move from degrees to radians, you multiply the degrees you have by pi out of 180 degrees. Any question on that? Okay. Examples. So we are converting some of them to degrees, from degrees to radians, others from radians to degrees, as we can see. Therefore, the first one, A, you're converting 5 out of 6 pi radians to degrees. We have seen 1 radian is equivalent to 180 degrees out of pi. So if I have 5 out of 6 pi in radians, they will be equivalent to 180 degrees out of pi times 5 out of 6 pi. I lose the pi by 6 once, by 6, 30. Therefore, 5 out of 6 pi in radians is 150 degrees.
Pardon.
Pardon, where? Did you understand? Did you get what 1 pi radians is? Or 1
Yes.
radian is?
Yes.
We are moving from radians to degrees. So the radians you have, you just multiply them by 1/8 over pi, because this is 1 radian. So if I have 5 over 6 rad, yeah? Now, if I assume this is the 1 radian here, I place there 180 out of pi, and I multiply. That's what I've done. Okay. Let's look at the second one. By the time I finish the examples, we shall be fine. 210 degrees to radians. We have seen that 1 pi in radians is equal to 180 degrees, okay? When I divide both sides by 180, I'll get 1 degree is equal to pi, 1 pi out of 180 in radians. So how many degrees do I have? I have 210 degrees. If I multiply them by 1 degree, I'll multiply 210 on both sides. Now I'll have my answer in radians. By 0, once, by 3, 7, by 3, 9. 210 degrees is equivalent to 7 pi out of 9 in radians. Hmm? 7 out of? Okay, by 3, 7 out of 6. This is 6. Okay, can you convert for me C? All of you try out C. answer I gave there, which I requested, frequency equals 1 over k squared m minus 2. Is it correct? What you crossed was very wrong. It would have been correct if you had said it is 1 over 2 pi times m power a half times k power negative a half. Yes, someone with an answer?
Five out of 6.
You get?
5 out of 6.
5 out of 6 pi. That is 150 times, okay, by 5, 3, by 3, 5, by 5 out of 6 pi, correct. Try out D. Jesse, have you got the 5 out of 6 pi?
Yes, sir.
Okay.
Study is not clear.
2 over 3 radians to degrees. 2 over 3 pi radians to degrees.
One 120 degrees.
120. Degrees, correct. Hope the rest have also realized those answers. Okay, so they can give you a question. Solve the equation tan squared x over 2 minus 3 sec x over 2 plus 2 is 0 for negative pi less than or equal to x less than or equal to pi. When they give you the range in pi, you have to express your answer in pi. So to start with, sec squared x over 2 minus 1 minus 3 sec x over 2 plus 2 is 0. When you solve this one, what do you get in terms of sec? But you have to show the method, don't just use a calculator. You either show bulldozer or factorization. So sec x over 2 1 and 2 will give me a positive 3 plus or minus under the root of 9 minus 4 times 1, or is over 2 times 1. Then when you do that, now you press your calculator and give me the values of sec. So sec x over 2, what do you get? Values of sec x over 2, what do you get? Guys, when you press the calculator, what answers do you get? Put this in a calc. Assume this is p squared, this is p. So you are putting a as 1, b as -3, c as 1. Hello? Guys, someone give me the answers. Are these people there? Yes, Maria. Do you have a calculator on you? Shakira. Shakira, are you there? Hey, people, I've told you assume sec is p. You are having a quadratic in this form. Put in a calculator, because now you've already showed us the method of solving using bulldozer.
.382 and 2.98.
And 2 point?
2.98.
But remember sec. Sec is 1 over cos. Yeah? So 1 over cos of x over 2 is 0.382. You see that cos of x over 2 is 1 over 0.382. But this one is impossible because it is going to give you a value greater than 1. Okay? That one is impossible. Then the other one is possible, which is equal to 2.1618. Therefore, 1 over 2.618 is equal to cos of x over 2. Cos of x over 2 will give us, what answer do you have? Will give us 1 over 2.618. So we need x over 2 as cos arc of 1 out of 2.618. This gives me x over 2 as what? What do we get?
$67.54.
67.54. Now, if you look at all students take cocaine, 67.54 is there and here. So the negative and the positive are both correct. So the negative 67.54 is also correct. Now, you don't need to find other angles because if you find other angles, you have to cross multiply to get x. So when you cross multiply, what do you get? You get 135.08 degrees. The second revolution of that would have been 292.46. But 292.46, it is here. 292.46. When you multiply it by 2, you would get 584.92, which is beyond. That's why I was saying these ones, you can leave them out. Okay. Then you also have x is equal to negative 135.08. But now, those are the two only possible angles which are positive and negative. But the question gave the range in pi. So you have 135.08 degrees to convert to radians. Remember, 1 degree is equal to 1 pi in radians out of 100 what? 80. So therefore, I'll get 135.08 degrees is equal to 1 pi times 135.08 out of 180. Now these are what? Radians. What answer do you get? You leave pi in your answer, you'll end up having 13508 out of 18000 pi. When you simplify this, what do you get? By 4, you get 377 pi. No, 3,000.
337 over 4,500.
Over 4,500. Good. Both positive and negative. So the negative 135.08 is going to be a negative 3377 pi divided by 4500. So the solution set becomes negative 3377 out of 4500 pi, comma, 3377 out of 4500 pi. Some people would write plus or minus. Okay. So the idea was here that if the question is set and the range is in terms of pi, then get the solution in terms of what? In terms of pi. Time is overflying. Take a screenshot. Now the exercise I wanted us to look at is solve the following. Equations for values of x from negative pi to 2 pi. So A, cos squared of 2x plus 4 sine of x cos of x is equal to 0. B, 6 tan squared of x minus 4 sine of 2x is equal to 1. C, sine squared of x minus 3 sine of x plus 2 is equal to 0. Let me try B. This is sine squared. No, let me try the last one. This is squared. So trying out the last one straight away. We can see that sine squared of x, two numbers multiplied, you get negative positive 2, added you get negative 3 is simple 1 and a minus 2. So you get sine of x into sine of x minus 1 minus 2 into sine of x minus 1 is 0. So you get sine of x minus 1 into sine of x minus 2. So sine of x is equal to 1 and sine of x is equal to 2. This is impossible. What? Why do we have that as impossibility? Because the maximum value of sine is 1. So this one will give us sine of x is equal to 1, and thus x will be equal to 90 degrees. The second angle is 450. Because when you look at the revolutions, sine is positive all here and here. So the first angle is here. That one only has one angle. So then you come back for the second revolution, which is 450. But now, because they said give the answer in pi, then the negative of it, okay, comes from this way up to here. The negative of this is negative 270. So we have negative 270 as another angle. But negative 270 is out of the range because negative 180 is the negative pi. Then 2 pi corresponds to 360. So these two are all out. We are only left with 90. Therefore, x will be equal to, remember we have seen that to convert the degrees, 1 degree is equal to 1 pi in radians out of 180 degrees. Therefore, our x will be 1 pi out of 180 degrees times 90. You lose this to that. This is now in radians. So x is equal to pi over 2 radians. So you can investigate for all the other angles you have. 60, 70, 60, 45, 30, those obvious angles. You can easily express their radians and get them without any challenges. Okay, our time is up. I think we can stop there for today. Finish up the rest of the numbers. Then if you can read about the other formula, which we shall introduce.
Teacher, may you please go back to the previous page? I've not taken a screenshot.
I'm sorry, the previous page got off because we lost network somewhere. Whenever you lose network, the page disappears. This is a fresh page. Was there a problem or you wanted a screenshot?
A screenshot seems I've been off the lesson due to network.
Okay, I will post the lesson as well on my YouTube channel, but someone please share to her the screenshots. Someone please share in the group so that she can have them. Okay, we have a nice day.